All right, this is part 3 of the rational functions videos. We looked at the vertical asymptotes and holes already, and then we looked at the horizontal or oblique asymptotes. X-intercepts and y-intercepts are next, and then we have quite a bit of information to graph, but rational functions are weird, and we need usually a lot more test points, a lot more values to point plot if we're doing it completely by hand to kind of get a good idea of what's going on. So I think once we have the key information here, I'm going to go ahead and flip over to GeoGebra and just show you how the graphs do look and some of the key things that we found algebraically, and we'll look at how it looks on a graph. All right. So first one here, vertical asymptote of x equals -1, and then we had this oblique of y equals x minus 5, and no holes. All right, since I did that in pink, let's go ahead and do the asymptotes in pink. One thing to note, the asymptotes are not an actual part of the graph. Okay, they're drawn in there to show, like, we're not all perfect artists, I suppose, and really it's too hard to get everything in perfect precision here. But if I draw the asymptote here at x equals -1, okay, for that vertical asymptote, I now know even if I mess up a little when I'm drawing my graph, I could see that it's intended not to cross that line. All right. Okay, y equals x minus 5 is the oblique asymptote. So we graph that line. I didn't scale any of the y-axes yet because it's really gonna depend on the scale. Kind of like when we looked at polynomial functions, sometimes we had to zoom out so far where I needed to see, like say a point appear up in the 60s or so. So it's really hard to scale this, but for this video, I'm going to go ahead and do it, and then we'll just do a double check in GeoGebra. All right, so down here at -5, we have y equals x minus 5, right? That's the oblique. And so a slope of 1, y-intercept of -5. So that oblique asymptote is going to do this. All right. Now let's look at the other information. So I'm done with 1, did my vertical asymptote, I did my horizontal asymptote. The zeros are the x-intercepts. Most of these will factor very nice for you, and you'll be able to see what they are. And the denominator sitting equal to 0, right, gave us the asymptotes, or the holes. That's where it was undefined. We cannot divide by 0. However, setting the numerator equal to 0, we can have 0 in the numerator as long as it's not both in the numerator and the denominator. And in that case, we would get a hole, like example 2, right? These x plus 3's cancel. So even though I would have x equals -3 would be a 0 because it's 0 in the numerator, but it's a undefined, right? It's not in our domain. That's what shows us it's a hole. That doesn't happen in this first example. So I could tell by inspection that x equals 3, the x-intercepts, is going to be x equals 3 and x equals 1, right? And as a point, we would write 3, 0, 2, 3, 0, and 1, 0. All right, those are the x-intercepts. The y-intercepts is if we set x equal to 0, right? It's somewhere on the y-axis here. So, I'm sorry, set x equal to 0. And I would rather look at the unfactored set because if x is 0, right, then this is 0, this is 0, this is 0, and I get 3 over 1. So f of 0 is 3 over 1, which is 3. So the y-intercept is 0, 3. That was kind of coincidence that I went up 3 right there, and I got y-intercept of 3. Well, looking at this graph now, I mean, I don't really know what it's doing. Okay, my guess in the middle here is that it's going to kind of look like a slanted parabola to some sort, like this-ish. But I don't know about the rest. So again, if I were to take a guess, I would think down here it's going to do something like that where it's still following both of those asymptotes. But we will check that out in GeoGebra. All right, next one. Vertical asymptote, x equals -1. Horizontal asymptote, y equals 1. There is a hole when x equals -3, and in fact, we found the value. It was -3, -2. So right here is a hole. Okay. What else do we have? That is it. All right, so the zeros. I have if x equals 1, right, in the numerator, would be an x-intercept, so 1, 0. 1, 0. All right. So step 3 is good. Step 4, the y-intercept, I plug 0 in for x. So all of that stuff cancels, right? Like, I mean, not cancels, it's 0. So I have -3 over 3. So f of 0, or g of 0, I'm sorry, for this one, is -3 over 3, which is -1. So I have a y-intercept of 0, -1. Okay. And that's really all I have. Now, again, I could speculate what this graph is doing. My guess is probably something like that. Now, remember, you can cross a horizontal asymptote, but as it goes to infinity, so I'm going to do it in a different color. Like, suppose we had a crazy graph. It might go above and then down, but as it goes to infinity, it gets closer and closer to that asymptote. Okay, for this one, though, again, we'll check in GeoGebra. I don't really know. Now, with this hole down here, again, a guess is that this is probably going to do this, but we'll pull that up. Actually, while we're at it, let's go ahead and look at these first two. I don't want to get too far ahead. So, GeoGebra. I had put them in here. I just couldn't remember what they look like. All right, so here's where I was talking about the scale. Right, I'm about, I mean, I could see down to -8, and it looks like nothing's down there. However, right, zooming out some, you could see that there. And you could picture that it's not drawn in here, that vertical asymptote, x equals -1, right? And the slant asymptote, we could actually put those in there. X equals -1. Okay, enter. And then, what was that other one? Y equals x minus 5. Enter. Now remember, they're not part of the graph. I put them in there so we could kind of see, and actually I think we could make it dashed, but yeah, there we go. So that kind of looks better. Settings, style, dashed. Okay. So now we can see the asymptotes, and they don't cross, right? They get really close, but they do not cross the asymptotes. And another key thing with this is I really didn't know where that graph kind of started, right? And you could see it, the values down here. I really needed to scale down to -12 to start seeing those values. All right, let's hide those and look at the next one. All right, so I did something wrong. I think I could see what I did wrong now. Easy mistake with the hole. So let's go back and take a look at that. Okay, I had said the hole was -3, -2. Yep, there's my error, and I must have made an error in the video as well. When I substitute -3 in the simplified version right here, that should have been -4 over -2, which is a +2. So -3, +2, hole here. And that's why I was incorrect with that. And it actually did something like that. Alrighty. So hole at -3, 2. Well, looking at this, I don't see any hole there, right? Here's the reasoning that they are graphing millions of points within a split second here. And they have points even at -2.9999 and -3.0001. We can't really see that hole in this graph. No matter how much we zoom in, I mean, there are infinite points there. Okay. So technology is a guide. We still need to understand what these graphs look like, kind of the basis, the foundation of them. But technology is a guide to help us. Now in another video as well, I showed how to look at these table of values. So if you did want a couple extra points, I don't know, let's go -5 to 5, I guess. And we'll leave the step at 1. That way we could see all those values. And you can see that question, -3, 2, right? -3, there's a question. And -1, -infinity, okay, that doesn't really make sense. Technology is here for a guide. It cannot produce asymptotes. It cannot produce these holes. We have to understand the function. And I'll do another video with a word problem to see kind of what's going on here. Alrighty, we'll look at this last one. I don't know how to get rid of those, darn. But alright, there's the last one. Let's go back and look at what's going on there. Alright, vertical asymptote at x equals -1/2. Right there. And at x equals 3. 1, 2, 3. Okay. Hole when x equals 0 at 0, -1. So right here, there's a hole. What else do we need? We need the zeros. So remember that these canceled. So there's only one 0. There's only one x-intercept, and that's when x equals -3. So -3, 0 is an x-intercept. The y-intercept is if I substitute 0 in for x, but I would end with a 0 over 0. H of 0 would yield 0 over 0. So there is no y-intercept. And this hole kind of confirms that anyways, right? Because it was on the y-axis. That is all we get for this one. And here's where a table of values, right? X, if you're doing it completely by hand, I'm going to need to test a lot of values to kind of see what's happening. Like what is happening in this region before this asymptote, what's happening in here, and then something happens over here in 3 separate regions since there are those 2 vertical asymptotes. Again, we'll pull up GeoGebra. And there it was, right? Except for there should have been a hole right there. And if we pull up this table of values, we would see that. Okay. -1, question mark, 0, question mark, some couple question marks all over the place, negative infinities in there. Oh, I'm seeing g of x and h of x. Oh, figured out how to remove those points too. There we go. That looks a little better. Now I can really see what's going on. Alrighty. And the last thing is, I didn't draw it in here, but there was a horizontal asymptote of y equals 0. As we saw, this left region has an x-intercept, right? And that's okay. It's just whatever it does, as it goes backwards, it is going to approach 0 again. And then we saw this guy did something like that. And this one was something up here. But again, we would really want to do a table of values to be a bit more precise than this rough sketch, right, that we have here. So I was just looking at one last thing. Something with this asymptote doesn't look right, and I wonder if I copied it incorrectly. X squared plus 3x. 2x to the third minus... Oh, yep. I forgot a 2. It's going to change it slightly. Darn it. That's okay. Now we could see that asymptote a bit better there. At the vertical asymptote at x equals 3. I was slightly off. Alright. That's usually the mistakes I tend to make, is typing something wrong. I just forgot a 2 there. Right? Earlier I divided a negative by a negative and I kept it negative. Little mistakes.